Calibration, folks. If you're going to build an engine, not assemble it, but build it, calibration on your precision measurement tools. So we're about to start measuring the piston bore clearance on our pistons for our Pontiac 350 stroker. So the first thing we're starting with is we're going to measure our diameter of our piston here, right here, somewhere here on the skirt, about midway. I know there's maybe somewhere around here within the pin. This is where I measure here. And I also take measurements up here, but this is what's important, this part right here. And that's where I measured anyway. Correct me if I'm wrong, you guys and gals, let me know. But really quick, if you look, we have an outside micrometer. Is what this is. This is a kit that has, I believe it was a Fowler. I cannot remember the name. It may not be a Fowler, but I've had this for a while. These are your standards. So it goes 0 to 6. These are the standards for each dimension, and then these are your ones for each size, 1 through 6. Actually 0 through 6. So right now we are on the, I believe, 3 to 4 standard. So we use the 4-inch standard. Now, as you can see, this thing's already off. It's out of cal. You look right where the zero's at down there, right there. I don't know if my fat fingers can show it or not. Let me see the light, see if I can help you. We are off by 2 thousandths. So, how am I going to correct that? These micrometers come with a tool. This tool right here. This tool is going to hook up to the bottom of the barrel. Okay, folks, you can see this micrometer was off by about 2 thou. That can make a big difference in an engine build. So this is the tool. You got two measurements, two adjustments. You got the large one that's on the barrel here, and the one for the thimble. So now I've adjusted the barrel where I can see it. It's on the standard. You can see I'm on 4-inch standard. Now watch the 0. And that's pretty close, right there. So, just want to let everybody know, when you use your standards, you use your micrometers, it's all about making sure that they're calibrated. Another thing is, don't ever throw your precision measurement tools around. They need to be kept, they're kept in a wooden box with cushions. Again, hope everybody got something out of this. Again, precision measurements, what it's all about. Yep, pretty close. Okay. All right. Looks good. Now let's measure the bore. Okay, just really quick, this is the Ross piston instructions and technical data from their piston set. So I always go over all of this. So when you look, they give you a sample size and their pistons. You've got position 1, position 2, and position 3. Most of the time I will say that I'm usually measuring position 3 right in there. Sometimes right there just below the pin below center. So if you look at all their sample sizes here, what they got, and you got to remember I stayed in position 3. My micrometer was getting me right at, now this is in 10 thousandths, mind you, this is tenths. Mine was going in right just under 3.902. So on this one here, I would say we're pretty close, within tenths. So they got 3.9013. I was probably at 3.9018. 019. This is done with a CNC machine, so they're much more accurate than I am with my micrometer. But my micrometers get me pretty darn close. It seems like they have so far. So just want everybody to know, you're going to build an engine. This is how you build it, not assemble it. Use your precision measurement, and you go back and you verify. And right now, we're good. And there it is, right there. We're pretty damn close. Right at . With our standard, yep. Let's check another one. There we go. Right there. So that's going to put us, yep, 3.940. You see that right there? That's it. So that's going to put us at 3.9 with our standard, what we subtracted. That's going to put us right there at 3.905. So I would say I'm within a half thou. And again, this is my bore mic. So gone in, measured the holes. This is a really well-known machine shop up here in the River Valley area. But I'm new to them. I've never used them before, and everything that I've been using has checked out. They've got about, I think, probably 50 years of racing experience building high-end dirt track engines, drag engines, and the gentleman that runs the machine shop is extremely well versed in his machinery. And we toured the machine shop there, and yeah, checks out. So going from a great machine shop that we had in Texas, you know, you always felt comfortable with what you had, and everything seems to be checking out. So looks like our piston to bore clearance is set, and we're going to move on to our main bearing clearances next. Always want to make sure you lubricate your bronze bushing that's in the rod. Now, this is where it gets very important. I'm going to install the rod with the wrist pin to show the process, but I want to show everybody the orientation. I already know which way it needs to go as far as putting this in. But anyway, we're going to get into that, but just want to show how everybody just to go easy as she goes on your wrist pin. There. Okay. All right. There we go. I like to start this into the piston, and then I just kind of hold the rod, and I twist it and just turn it. It'll eventually. Okay, so it's found center, and now I'm just going to kind of slowly. There it goes. There it goes. Okay, see, right there, just pushes right on in. Okay, now this is what's very important. Now, these rods are for a stroker engine, and any stroker engine that I know of, usually with the rods, there is a chamfer. You see this chamfer? There's a chamfer here, but this side there's no chamfer. On a stroker crank with your stroker rods, it's imperative that the chamfer here always goes to the counterweight. It will face the counterweight of the crankshaft. So the chamfer is going to go right here. And what that does is, there's a radius there, you can't really see it, but that allows it to float, and it keeps it prevents that from getting into a bind. I had an engine, a big block Chevy stroker come in, the guy had it rebuilt twice because it kept breaking wrist pins. And that was because the previous builder didn't pay attention to the radius on the rods. He had them in backwards, and it put the rod in a precarious position, and then it put pressure, side pressure on the wrist pin, and eventually broke the skirt. So that's one piece of it. Now here's the other part of it. I brought the cylinder head out because we have to pay attention to what we're doing here. Some engines have what we call an intake, exhaust, intake, exhaust, intake, exhaust. Some engines are intake, exhaust, exhaust, intake, and so forth. This is imperative. So this is going to be our driver's side cylinder head. Now if you look on this engine, this is going to be the #1 cylinder here. If you look, the exhaust port is outboard and the intake is inboard. So it goes exhaust, intake, intake, exhaust, exhaust, intake, intake, exhaust. I think like small block Chevys, when I build them, they're always intake, exhaust, intake, exhaust, intake, exhaust. Big block Chrysler, I believe, same way. It goes on. 409 Chevy, I think, is intake, exhaust, exhaust, I can't remember. Anyway, this is very important. So now you see the reliefs, where my intake relief is at. When I get ready to put this in, I haven't put my spiral locks in yet. So when this goes in, this intake is going to be here. Okay? The intake is going to be on the inside. The intake is on the inside, because you don't want to take spiral locks back out. Something else I did, this is just me, you guys that build more engines than me, that's fine. But I've gone in with a block, and so I know that when I put the pistons in, one last minute before I go twerking everything down, I've got exhaust, intake, intake, exhaust, exhaust, intake, intake, exhaust. It's just another last minute reference. I know there's going to be comments, probably people say I'm stupid, and that's fine. That's fine. But when you build several different brands of engines, you just have to stop what you're doing. When you build different engines of different manufacturers, this is imperative to take your time. Okay? Guys that build small block Chevys, it's easy, they're doing the same thing over and over and over and over. Or an LS, they're doing the same thing over and over. A Gen 3 for that matter, I don't care. But when you build a Pontiac one day, and you build a Ford FE the other, and you build an Oldsmobile, then you build a big block Chrysler, you've got to pay attention. So this will really frustrate somebody. I've been there, I've done it. I put spiral locks in because I wasn't paying any attention, and I had to go back, and you pull spiral locks out, they're not fun. They're not fun. They're really not a lot of fun putting in. But anyway, I just want everybody to see this, so we're gonna carry on. Now we're about to put our spiral locks in. Spiral lock time, yay! So, anytime you're building a stroker, 9 times out of 10, you're gonna be putting spiral locks in. So spiral locks, what are they? They're just a kind of spring looking thing, little coil, and they go into a groove where the wrist pin's at. So if you see that right there, there is a groove. And most of the time, not all the time, but I would say 9 times out of 10, each side requires 2 spiral locks. So we have already put the other side in. As you can see, it's floating like it's supposed to. So to get started, I use this little small flat-headed screwdriver. It helps me get into the groove. Everybody's got a way they do this. There's a tool that's actually made for spiral locks, and there's actually several tools because of the different diameters. And they made one out of plastic or Teflon, I think, and there was one made out of steel. The one made out of Teflon, I think, was probably maybe $120. The steel one, aluminum, whatever it was, I think that was like $380. So to only be able to do one series, like a big block Chevy or a big block Chrysler. So if I buy a tool that expensive and I can only do one engine family, then I'm not going to buy it. I'm not that big. But the plastic tool I had, it lasted maybe 6 pistons, and the Spirolocks ate it to bits. But I just have to go back and I do like most people do, and I do it by hand. So you take that Spirolock and you kind of just pull it out and you unspring it. And you actually got to kind of have a little bit of a thumbnail to get in there and get to it. But you find that one side, and then you're going to come in, you're going to try to get it in on the groove. And Trish's going to try to help me hold it a little bit. And then I am going to see if I can get it started. I'm just going to push it in. I'm going to take my time. There we go. It's going in. My fat fingers are in the way of the camera, but you get the idea. And there it goes. And then what I got to do is I just kind of move it around so it's kind of like coiling it in. It's like just putting a coil in, because that's what it is. It's a coil. We're going to get it in there, hopefully. Come on, baby. There it goes. You see it's just kind of go around. Well, and it came back out. Once it gets in the groove, it'll start. I'll move the piston around. You just gotta go a little bit at a time. Obviously, I pull the other coil up. This is why it has to be uncoiled. Trying not to mar the piston. There it goes. I'm just taking my time, folks. There it goes. You'll see it and you'll hear a click here in a second. There it goes. So that's one. Now I'll put the second one in. Set the second one in. Usually it goes a lot faster than this. We're trying to run the camera, and I want to tell you a little trick to this, but I just want to show everybody how they go. One of the things that's kind of fighting me the way I did it the first time, or on this one here, you put the first set in without the wrist pin in, and then slide your wrist pin in. But I wanted to show everybody, make sure we had proper orientation on the rod and the piston. So the second one, depending on how much clearance they give you, some of them, they don't give you much clearance at all in this groove. I forgot what other type of locking device it is. There's another locking device that we've used, and that they are easier, I believe, if I remember correctly. See now how this one's going in real easy? Once you get in the groove, you'll see, oh yeah, now I'm in the groove and I get them, no pun intended, there it is. So you saw the first one I did on the other side. It took me a bit. It's been a while since I put Spirolocks in, but once you get into this, the rhythm, they'll go okay. But this is very important. Now, you see why, because of putting this Spirolock in, that it is extremely important to make sure that your rod is oriented properly to the crankshaft with the chamfer that we talked about. Number two, make sure that your reliefs are oriented oriented properly to your cylinder head. So we're not going to bore everybody with the rest of this. We're going to be moving on. It's going to take us a couple hours to get here, but we hope that everybody got something out of this. So hope everybody has a good weekend. Thanks, everybody.